Hello! Today's lesson will cover the second half of 10.4, but first we have a warm-up question where we are going to look at the fundamental counting principle once again. So it says, how many different outfits can you make from 4 t-shirts, 5 pairs of jeans, and 5 pairs of shoes? Remember that all you have to do to find the number of options is multiply each event number of options together. So 5 times 4 times another 5. We have 5 times 5 is 25. And when you multiply that by 4, you will get 100. So there are 100 different outfits. Okay, next what we are going to focus on today is called a compound event. So a compound event consists of 2 or more events. Okay, so let's see how it would be used with probability. So it says, in example 2, what is the probability of rolling a number greater than 4 and flipping a tails? Okay, so this is where knowing all the possible options, the sample space, comes in handy. Okay, so we created this last video. This is just a nice little neater. And remember, all of these different options, that's the sample space. So there were 12 total options. That's always the denominator, the total, right? Okay, but now we have to look at, we want the probability of rolling a number greater than a 4. Okay, so we can only look at numbers greater than a 4, which would not include a 4, because 4 is not greater than 4. And flipping a tails. Okay, so now we're going even more specific. So it has to be either a 5 or a 6 and can only be a tail. There are only 2 options out of the 12, so the probability is 2 out of 12. Your big ideas especially wants you to simplify this, so let's divide each, the numerator and denominator, by 2, and you will get 1/6. Okay, I changed our next question on us. Number 2 says, in example 2, what is the probability of rolling an even and a heads? Okay, so it's really nice again to have this sample space all laid out so you can look at all the different options. Okay, so you can only roll an even, so I'm just going to get rid of all of the odd numbers. And you can only flip a head, so I'm going to get rid of all the tails. And that leaves us with a 2 in the heads, a 4 in the heads, and a 6 in the heads. So that is 3 possible options out of the total sample space of 12. Again, let's simplify this by dividing both the numerator and denominator by 3, and we will get 1/4. We worked very hard in our probability unit, or excuse me, our percent unit. If you did 1 divided by 4 in your calculator, you will get out 0.25 or 25 hundredths. And if you multiply that by 100 or move the decimal 2 places, you will get that decimal as a percent. So 1/4 is also 25%. Okay, so finding the probability of a compound event. Okay, so you flip 3 nickels. What is the probability of flipping 2 heads and 1 tails? Okay, this one is actually a little more complicated than you think. Okay, so whenever you are finding the probability of a compound event, you want to draw out those either tree diagrams or the tables. Okay, so for this first coin nickel you're flipping, you could either flip a head or a tail. Okay, again, that is coin 1. So now coin 2, off of that first head, you could flip this second coin and get a head or a tail. Or if you got a tail to begin with, you could flip it and get a head or a tail. Okay, now you're doing your third coin nickel, and you off of this head you could flip a tail or a head as well, a head or a tail, a head or a tail, and a head or a tail. Okay, so drawing this tree diagram really helps us to look at all the different options. Okay, so now I'm just going to list all of my different options I could have. So with this first coin, I could have flipped a head, and the second coin I could have flipped a head and then a tail. So I'm going to list that off as head, head, tail. Okay, so that was our first option. Or we could have flipped a head, head, head. Okay, next you could have flipped a head, tail, head. Or a head, tail, tail. Okay, so why don't you pause the video now and you try listing off the rest of this sample space for the second coin that would originally be flipped as a tail. Go ahead. So you should have gotten a tail, head, head, a tail, head, tail, a tail, tail, head, and a tail, tail, tail. Again, this is our sample space for flipping 3 coins. Okay, so you see that there is 1, 2, 3, 4, 5, 6, 7, 8 different options. Okay, so that is going to be the denominator. And it says, what is the probability of flipping 2 heads and 1 tail? So now out of all the different options, we have to go back and look for the options that have 2 heads and 1 tail. 2 heads and 1 tail. 2 heads and 1 tail, 2 heads and 1 tail, and that's it. So that probability is 3/8. And finally, I'm going to do this in red. What is the probability of flipping at least 2 tails? Okay, so out of 8 again, at least 2 tails. This option does not have 2 tails. This option does not have 2 tails. Does not. But this option has 2 tails. This option has at least 2 tails. This option has at least 2 tails. And look at that, even this option has at least 2 tails because it has more than 2 tails. It has 4 tails. Okay, so I'm going to count up all the red options. And that is 4/8, also known as 1/2. Okay, so these questions with compound probabilities, so multiple events happening. So with the nickels, it would be multiple nickels being flipped. It's actually a little bit more confusing than it looks. So my suggestion is whenever it's asking a question like this, you want to draw this diagram out, okay, and list off your sample space so then you can look at it to answer your questions. Okay, so today we looked at compound events, okay, meaning consisting of 2 or more events. And we have not done this before because with the probability, we just found the probability of 1 event happening. Now we're putting 2 events together, right? The coin is 1 event. Now the rolling the cube is another event. What is the probability of something happening when that situation occurs? Okay. Please let me know if you have any questions.